Hello and welcome to Tech Dictated. Today we are looking at flip-flops and latches. It's going to be a series of flip-flops and latches. These are the building blocks in digital electronics, and so we have the latches than the flip-flops. The latches do not have a clocking mechanism. These ones have a clocking mechanism, and that's the major difference between the two of them. And then what the clocking mechanism allows it to do is that when the clock is low, then nothing happens. No matter what you change, no matter what input you're changing, nothing happens. But when the clock is high, that's when change can actually be made to the flip-flop. The latch, change happens immediately and input is changed. So that's what we're going to be looking at. Then these are they're used as storage elements, and they are the basic storage elements in sequential circuits. So we're going to start with the Sr Latch. In this Sr Latch, either this output is high or this other output is high. So we have two inputs, okay? We have the S input and the R input. S is set, R is reset. And then whatever the input, this is a Nand gate, okay? A Nand gate. And whatever the input is fed into these gates, we get an output, okay? So when this Nand operates in such a manner that it's opposite from the AND gate. So if you remember your gates properly, we have two inputs. Let's say we have two inputs, A and B, and we have an output, okay? Yeah, we have an output, or I should have used Y or something. So if we have an input 0, let's just use 0 and 1. If we have an input 0, let's start with the AND gate. Okay, so if we have an input of 0 in an AND gate and input B is also 0, okay, and then this is 1. Why am I just playing myself? 1. Okay, so let me just do this then. Okay, 0, 1, 0, 1. Let's say we have this as our input. In an AND gate, inputs when we only have the same input, that's when we have an output of this. Okay, this and this make a 0. 0 and 1, that's like 0 and 1, they're not the same. When we have the same value, that's when the AND gate is on, okay? When we have both as on, that's when the AND gate is on. This is on, this is off, okay? So off and on, this is off. Off, on and off, this is off. Both are on and this is on. This is in an AND gate. Now, for the NAND gate, for the NAND gate, we have it in the other way, okay? Let's say we have the inputs A and B. This is a truth table for the NAND gate, and the output O. Or this O is confusing. Let me just use Y here and this as Y, okay? So we have A, B, and Y, 0, 0, 1, 1, 0, 1, 0, 1. So when both outputs, now in this one we were saying when the outputs are true, both are on, then we have an on. So you just reverse this, okay? So this will be 1, 1, 1, and 0. When both are on in NAND, it's not AND, okay? So it's not this. You just reverse the value that is here. That's an AND gate. So that's the logic we're using for this, okay? So now, this is the Sr Latch. We have an input here and another input here. And we have said that these are our outputs, okay? These are our outputs according to a NAND gate. This is the truth table for a NAND gate, okay? We have the truth table there. So now, we have two inputs and two outputs, right? So we have, let me just get one that I already wrote down so that we make this fast, okay? So we have this, let me just do it this way fast. This is the Sr Latch. This is the Sr Latch. So we have S can be 0, can be 1, can be 0. It's 4 possible. When there are 2, there are 4 possible scenarios of how this can go. So now in an AND gate, let me just put this back up so that we don't have to look at a lot. So in this gate, in an Sr latch. This is our truth table, and let me just explain how we get here. So we have two inputs. For the NAND gate, we've said when x is 0, okay, when the inputs are both 0, we have a 1, right? When the inputs are both 0, we have a 1. That's because when the inputs are both 0 in an AND gate, okay, not NAND but AND gate, the output will be 0, and so we inverse that, so it's a 1. The same goes for the remaining ones. And so for this, that's the thing we're going to use as our help. So when we have our inputs, when we have both our inputs, let me just start with the steady states. Let's start with a 0 and a 1, because for it to change state, for the Sr latch to change state, there must be one input as a 1 and another input as a 0, because it's an active low. So there must be a 0 for the action to change, for it to change between states. Yeah, so when we have our inputs as 0, okay, we have this input. Let's use the second one. When we have our input as 0 and our other input as 1, right? Then let's look at this table. Whenever we have a 0, that means the output will be 1, regardless of whether there is a 1 or a 0, because these ones are both 0, it's a 1. This one is a 0 and a 1, but this one is a 1, 1, and that's the only place we have a 0. Makes sense? So whenever we have a 0, that means the output on this end will be a 1 in a NAND gate. So the output here will be 1 regardless of this. And since we have this output, then we have this as 1. And so 1, 1 will be a 0 on this other end. Okay? And therefore our Q will be 1, our Q not will be 0. Okay? So let's look at it. 0, 1, 0, 1, 1, 0, 1, 0. That's because whenever we have a 0, our output is a 1 as long as it's a NAND gate, regardless of this other value. Okay? And that's what makes up the SR latch using a NAND gate. We can make an SR latch using a NAND gate and also using a NOR gate. So let's look at it with a NOR gate. Let's look at it with a NOR gate. We'll just use the same table. Then let's get the NOR gate. Okay, so let's look at this. The NOR gate, whenever we have a 1, our output is a 0. Let's keep that in mind. Whenever we have a 1, our output is a 0. Now, let's look at that. I will let me first start by explaining how this is possible. The NOR gate. So the NOR gate works such that it's not OR. Okay? Not OR. And OR means as long as 1 is on, then the output is on. Okay? As long as 1 is 1, the output is 1. So as long as 1 is 1, the output is 1 in an OR gate, not NOR OR. Now, in this case, it's 0, 0, so there is no 1. The output is 0. And because this is not OR, then we negate. We do the inverse, whatever it's called. So it will be a 1. 0, 1, there is a 1. So it would have been a 1 if it were an OR gate. But since it's NOR, then it's a 0. 1, 0, there is a 1. So it will be 1 if it were OR. But since it's NOR, it's a 0. Because it's not OR. And it's only 0 and 1. It's binary. 0 or 1. Okay? So if it's not 1, it's 0. That's the concept we are going with. 1 and 1. Then that would have been a 1 because both are 1. So it's still 1. But then, as long as it's a 1 or more, okay, it's a 1. But then, because that's the case, if it's an OR, then that means for this will be a NOT. Then it's a 0. So let's use that for finding the same thing. The same thing we did 0 and 1 with this circuit now. 0, 1. Right? The same exact thing. Now, we have a 0. We're using the NOR gate. Whenever we have a what did we say? Whenever we have a 1, the output will be a 0 regardless of whether the other output is a 1 or a 0. So therefore, whenever we have a 1, the output is a 0. And therefore, this will be a 0. Makes sense? And then 0, 0 is a 1. So our output is 1, 0. Q is 1. Q naught is 0. And this is the reset. This is the set. When we look at this, 0, 1. Okay, those were our inputs. 0, 1. And our outputs are 1, 0. 1, 0. So whichever you choose, whether it's the Nand or the Noir, they will do the same exact thing. Now, we have different states. That is a state that works, okay? We are changing, it's changing. Let's try another. We have 4, okay? So let's try another. Let's go to this. I will start with the ones that change, then the ones that don't. And then we proceed now to the next latch or flip-flop, whatever it is that follows. So 0 and 1, that's what we've looked at. Now let's look at, let me change my pen. Let's look at 1 and 0. That will behave exactly the same way. So let's say this is 1 and this is 0. Then, when we have a 1 on this upper side, this is an AND gate. Let's get back our AND gate. Okay. Whenever we have a 1, that does not matter, because a 1 appears whether it's a 1 or a 0 at our output. But whenever we have a 0, then the output is a 1. So whenever we have a 0, okay, our output is a 1. And therefore, this input will be 1. And therefore, 1 and 1 in an AND gate, NAND gate, 1 and 1 will be a 0. Okay, so our output, when the set is 1 and the reset is 0, our output is 0, 1. Let's look at it. When we have S as 1 and this as 0, our output is 0, 1, exactly the same, because we are using this gate. Whichever gate you use, actually, it will produce the same results. Okay, now let's use this to try the other one. Let's try this first one. So you've seen for the 2, the states are changing, right? At first we had 0, 1. At first we had 0, 1, and then the output was 1, 0. So the state changed such that this went off, this went on. No, this went on, this went off, right? And that's state changing. It's this, for this case, for the first one, when it's 0, 1, and then it goes to 1, 0, that's setting. When it's 1, 0, and it goes to 0, 1, that's resetting. Because this is resetting, this is setting, okay? That's how they're represented. Now, let's proceed to this first one and last one. Now, in the first one, we have a 0 in both entries. We're using a Noir gate, so we have a 0 here and a 0 here, okay? Now, when we have both as zeros, what does it mean? When we have both as zeros, it means we have a 1 at the output. Okay? So for this one, we have a 1 at the output. But also for this one, we have a 1 at the output. Right? We have a 1. So both outputs are 1. Both outputs are high. Okay? Both outputs are high. That's a state. But that's an invalid state, because then, okay, it's an invalid state, because then we don't know which one. Both are on, and it's supposed to be 1 is off, 1 is on. Then we have another one whereby it's 1 and 1. We have this one as 1, and we have this one as 1. And it's a NOR. So when we have one input as 1, we have no change on this end, okay? They remain as they were. We have no change in this end. They remain as they were. Okay? And that's it for the Sr Latch. So we have 4 states. We have the set, we have the reset, we have an invalid state whereby we don't know what is what, and that's a weakness in this Sr Latch, which we will correct. Okay, we will not really, but we will help make better with the SR flip-flop, which we're going to look at in the next video. So we have a no state change, we have an invalid state, and we have a set and a reset. Okay, that's that for today.